talk about Ubicom first, our products, then our smart energy saving system. In 2004, Research Institute for Ubiquitous Bioinformation Technology, UBIT, was established with $25 million funding from Korea Telecom and SK Telecom. In 2010, Ubicom was founded to commercialize technology developed by UBIT. Now, here are some of our products. Ubicom has a semiconductor division, and they are currently developing the power management IC for Galaxy S2 of Samsung. This is Galaxy S2, and this is the PCB inside, and this is our chip, PMIC chip. And mass production is scheduled for end of this year. We also developed the LDI driver IC for LG smartphones, and the technology for this uses 1-bit SRAM technology. Normal SRAM uses 4 transistors. This thing uses 1 transistor. That's why the same amount of memory for graphic interface requires less space. That's why it was cheaper. So we have a price competitiveness. Our second product is UBME, which is an advanced metering infrastructure solution. And what it does is, it uses wireless technique to read meters, gas meter or electricity meter or water meter, wirelessly using 4 megahertz to this concentrator. And this concentrator sends all the metering data to the server via the mobile network, where billing can be done automatically. And this thing saves on the amount of payroll for the meter collectors. And whereas meter collectors collect meter data once every month or so, this thing can collect data once every hour, giving you a complete picture of what's going on with your gas, electricity, and water. And we have 23 sites, 21 in Korea and 2 in Finland. And we'll be adding a 3rd and 4th site within next month in Finland. And we will be adding several more sites as well in Korea. Our third product is WEPS, which is a wireless electric power saving system. This was developed in 2006. And what it does is, we have an array of sensors. So when people enter the room, lights turn on and air conditioner turn on. When people leave, they turn off.
But you can control the timing, huh?
Yes. One problem with this was we had to get the neutral line from the corner of the room all the way to the device. So it took a lot of time to install the devices. That's why we developed EcoG Smart Energy Saving System, which is an improved version of WEPS. And the WEPS is currently installed and running in 30 university campuses and government agencies in Korea. EcoG is the improved version. And again, we have an array of sensors, and you can connect to the smart switch, which controls the light, or the smart plug, which controls air conditioners. The status of all the devices go to the coordinator, which sends the data to the central control system. All the commands go the other way through the coordinator to the devices. And it uses IEEE 802.15.4 wireless communication protocol. The key features are significant energy savings, convenient operation modes, simple but powerful user interface, high scalability, fast and easy installation, and ideal for smart homes and buildings. Now, this is the difference between wired and wireless devices. Wireless devices cost more, about double the wired devices, but it costs much more. Wire systems cost much more to install. This is the installation cost. And that's why wireless devices are cheaper to install. Now, when you use occupancy sensors, this is the kind of savings that can be achieved. For private offices, about 30 to 50%. For common areas like restrooms and corridors, up to 90%. So this is our energy savings. This is an example of energy usage by building type, all types of buildings, and basically most of the energy is used for lighting, air conditioning, and heating. So in Malaysia, most would be used for air conditioning. Here is the savings achieved by the websites. Average energy saving rate was about 22% for lecture halls lighting, 67% for washroom lighting, 29% for air conditioning. For some of the sites that only use air conditioning, the ROI was about 1.7 to 2 years. When they used both air conditioning and lighting, ROI was about 2.6 to 3 years. For just lights only, it was about 3.4 years. Here, these are some of the 30 sites we have for us. So here's an energy savings example. Suppose there's a 4-story building with 6 large and 16 regular offices and 4 washrooms on each floor. So total of 88 offices and 16 washrooms. And air conditioners are used 8 hours a day for 5 days a week for 4 months a year. In Korea, for Malaysia, they will be longer.
12 months a year.
Yeah.
Every day you use.
Lighting is used for 12 months a year. For air conditioner only, a peak instantaneous electricity usage is 278 kilowatts. This can be reduced about 30% with the installation of EcoG. For savings of about 53,000 kilowatts per year for this building, which is equal to about $9,500, according to based on Korean electricity rates, which consists of basic rate and usage rate. For air conditioning and lighting, peak usage is higher and you get more savings. Second feature is convenient operation modes. Air conditioner and lighting can be turned on and off using occupancy sensor. This is local control or central control modes. We have schedule mode for both air conditioner and lighting, and temperature mode for air conditioner, light sensor mode for lighting. And this peak control mode it saves energy by turning air conditioners in building on and off according to a period set by central control. So, for example, you can turn it on for 20 minutes, turn it off for 10 minutes, for let's say 2 hours. These are all settable so that during that period you're saving 33% just by turning off. And these different control modes can be prioritized differently depending on your needs. So you can make this the highest priority mode, or you can make this the highest priority mode. And manual override is also possible. We have a simple but powerful user interface. For this whole campus, each status of energy use for each building can be monitored and controlled. And you can also control through iPhone or smart pad. All types of browsers are supported. Setting the schedule is easy using this graphical interface. We have high scalability. Each building would have one coordinator and as many devices as it needs. We can have many buildings. One site in Korea has 10,000 of these devices, but we can also expand it to 20,000, 30,000 as much as possible. We can also scale down to one home with 3 or 4 rooms. So this, in terms of scalability, our system is very flexible. And setting them up is easy using this graphical interface.
But your signal is by what?
This is a wireless, like Zigbee. And to the internet, we have a wired internet connection.
Wireless always think it's wireless. Like I said just now, wireless is cheaper in the end, but wireless also has its related problem. Yeah. Wireless also has its related problem.
Yes.
Just like alarm system and all this.
Yeah.
Wireless is definitely not as dependable over a long-term period compared with the wired system. Even though your cost may be cheaper now.
Yeah.
But over a long-term period,
yes,
the dependability and the durability of the system,
yes,
compared with the wire system, may not be that good. Because you see your project is only since 2005, 2006.
Yes.
So you put in the market 2008 or whatever. So the lifespan of your thing is still not very long, you know. It's just like a medical device.
Yeah.
You use a medical device, a stent, example, do a angio.
Yes.
You know, initially you should have problem.
Yes.
It's over the years after you have used it and the thing is durable, then you can say this is a very good device. So yours is still at its infancy stage.
Yes. So actually, we started installing that in 2006. So it's been 6 years, and systems have been running fairly robustly because they're based on basically RF communication chips, which is very reliable.
And most wireless here are not using ZigBee. Receive wireless using ZigBee, am I right?
Yes.
Yeah. ZigBee is better than, and the one we have in our office, they don't use ZigBee. That's why it's not right. ZigBee is